I think it's a tremendous help to actually be aware of what the actual numbers, when we've got, say, y equals mx plus c, what happens as we change m, what happens as we change c, what effect does that have on the graph? So what I'm going to do is look at a starting point, some standard equations, and then just see what changing m does and what changing c does. And I think that if you can understand that, that will help you with a lot of this work. So let's draw ourselves a good set of xy axes on the Cartesian plane. Now, the equation of y equals x, so y equals x has a gradient of 1, and so this would be y equals x. So m is equal to 1. And it's around about, the rise over the run is equal to 1 over 1, so the gradient's 1. So in fact that's actually a 45-degree angle if these have the same scales. So if you're going up by ones, going up by ones. Obviously if this is going up by ones and this is 2, 4, 6, 8, well then it's not going to be. But in this case, if you've got the same scales, and let's not complicate things, the gradient is 1 and that angle will be around about 45. So it's about, it cuts it right through the centre there. Y equals 2x is simply twice as steep. So y equals 2x, in this case m is equal to 2. And where would we draw, so once again, the c value is 0, so all values, all equations of y equals mx just go through the origin, O for the origin. And this one here, about halfway between the two, is y equals a half x, so m is equal to a half, the gradient is a half, and so on. You know, a quarter x would be like this, would be not as steep. Okay, well, what about negative gradient? So if m is equal to -1, it would be at 45 degrees that way. So this is y equals -x, m equals -1. It falls as we go left to right across the page. Y equals -2x, m equals -2, and y equals -1/2x. So m is equal to -1/2, and so on. Okay, so that's what m does. What does c do? C is the y-intercept, we know that. So if we had y equals x, it'd be good if I could draw it through the centre, eh? So y equals x. Now, what does y equals x plus 1 look like? Well, we just go through the point 1, and there's y equals x plus 1. We know it's parallel, so y equals x plus 1. Y equals x minus 3. 1, 2, 3. Parallel. So y equals x minus 3. So the c value simply slides the basic graph up and down the y-axis. And that's all that's to it. So if you had y equals, let's say a third x minus 2, we could start off with y equals x, y equals a third x, and then we're going to slide that graph 2 units down and draw it parallel to that one. So we've got to, let's see which one. We're going to draw it parallel to this one. This is y equals a third x. And I'll do this one in. So I'm going to draw this graph parallel to that. and this is y equals 1/3 x minus 2, going through the point -2 there. Okay, so that's just transformations of a linear graph. If we know what the effect the gradient, the m value, has, and then what the c value does, it just slides it up and down, vertical shift up and down the y-axis, and then we can put it all together and start just by starting with y equals x, then y equals 1/3 x, and then y equals 1/3 x minus 2.